All right, left off with this cliffhanger here of finding the angle between our radius and force vectors. Hopefully you figured it out already. If not, pause the video and go to it. Otherwise, here we go. So we just need to find the magnitude of r, which, as Pythagoras tells us, square root of the square of each added together. That's a horrible description. 3.6. Magnitude of f. Fancy math here. Now, we already know what the torque is. We figured that out up here. Okay, when we did it the correct way, we got negative 2 k hat. So the magnitude of the torque, that's all that's in that equation, which is negative 2 equals the magnitude of r times the magnitude of our force times the sine of theta. That's what we don't know. So our angle is going to be inverse sine of negative 2 over our two magnitudes, which in this case is 4.96 degrees, which hopefully you got. Okay, I have one more practice problem just for you to do, and that's going to bring in the concept of angular momentum. This is going to be our little crossover. And we already put in our big old equation sheet that angular momentum, big L, is the cross product between radius and our linear momentum. And remember, you got to keep that radius first. So crossing those gets our vector quantity for angular momentum. So for this problem, we have a particle traveling at a velocity of 4.2 I hat minus 3.6 j hat meters per second, and it has a mass of 1.5 kilograms. And the radius so it's going in a circle, and the radius of that circle is 1.5 I hat plus 2.2 j hat meters. So it is going in a circle, but I gave you linear speed here and the radius that it's going at. I want to know its angular momentum. Okay, so I know I need to do r cross with p. I have r, I don't have p. Okay, so I need to find my linear momentum, which, as you remember, p is mv, so I need to take my mass times my velocity. And just because velocity is in unit vector form, that's okay. I can take my mass times velocity, and I get a momentum of 6.3 I hat minus 5.4 j hat kilogram meters per second. All right, now I have a P, now I have an R. I can set up my matrix. Remember to put R first. So for my radius, I have 1.5 I hat, 2.2 j hat, and nada for k hat. And then put in your P values. I'm going to add my other I column and do the cross. Okay, so I hat, hey, look at all those zeros. That's neat. J hat, more zeros. Hooray. K hat direction. Okay, so when I do this, I get negative, so 1.5 times negative 5.4, gives me negative 8.1, and then minus 2.2 times 6.3, which is 13.86. So my angular momentum is negative 21.96 k hat kilogram meters squared per second. Okay, I think I'm gonna stop our video here. That's all I have on cross products. You'll need to be able to do them. And I'll see you next for angular momentum. If I can stop this.